we are taking this data set, and there are it is a huge data set. It is a huge data set. It is coming that nearly 10 lakh records are there. 10 lakh records are there.
Okay, sir.
And these are the columns are there.
Okay.
Yeah. Around 10 lakhs records are there, and these are the columns. This command
Okay,
we
sir.
are using the strip command to remove the blank space in the front and back. Sometime in the column name, some blank space will be there. That will create a problem. Okay,
Yes, sir.
to remove that, we are using that stripe command, and then we are giving the heading and other thing. Then we are going for a data pre-processing. We are looking for a null value. Any null values are there? Luckily, in your data, there is no null value, and we are looking for the infinite value. Infinite value means junk value. Sometime huge value will be sit in the column. Unnecessary values will be there. We are removing those things. This command, it is there. There is nothing, but this command will remove that both the
Mhm.
infinite value and the null values. It will be removed. Then after that, we are looking that in the data set how many records are there. There is a nearly there is a in the benign means normal. Normal we are having 6 lakhs record, and the scanning we are having one 3 lakhs 91,000 records are there, and that password
Mhm.
injection and DOS and XXS like that multiple attacks are there. But we feel that these attacks are which are very less. These attacks, these four attacks
Yes,
are
sir.
not
From
very
exercises.
less. So that we are dropping that four attacks. We are taking the top five attacks. We are taking that the benign up to this. We are taking totally. We are taking that the this much only. We are taking it up to sorry five first to five. We are taking that up to this. We are taking that. Okay. We are removing other things. Then after that we are going for a visualization. In the visualization you are looking that there is a benign and a malignant, all are very less amount will be there. What we are going to do means we are going to make it samples. We are going to take that each records we are taking a thousand samples. Here it is having 866 only, then DDoS now, so that we are increasing. It is called
Yes, sir.
upsampling, whereas the injection and password and scanning and benign we are doing
It
the
will downside.
upsampling. So that we are doing that the sampling will be, we are taking that the 1,000 records we are doing the sampling. Okay. Then after
Yes,
that
sir.
we are going to visualize the things. Everything will become thousand. It will be come into the picture. And now we are looking that all are, it is a balanced data. It is a donut chart. Everything will have the 20%, 20%, 20% will be coming. Now after that we are having that what are the attacks are there? Benign, DOS, DOS, and injection, password, and scanning. It is called a label encoding. Label encoding in the sense we have to give the benign 0 and DOS 1, some numbering system we have to do, because machine learning everything will accept the only the numbers format. So that we are changing that, so that we can able to see that
Mhm.
last column will be changed to the numbers it will become. Okay, that's all. And the next thing, this command is called the reshuffling. We are shuffling the things, reshuffling the this data, so that it will be in the, it is not in the it will be shuffled format. It will come, you can see here, it will be in that order will be
Means
come. And
why are we shuffling, sir?
for whenever we are going for the sometime no data set, all the attacks will be in the same place. We are splitting 80 and 20, that no, what will happen? No, it will come the last 20% attacks will
Okay.
be one thing will be there. We have to shuffle, and we do the train only, it will become the very good accuracy will get, so that we are shuffling that.
So for training purpose, we are doing shuffling. Okay.
And here we are dropping that these three things are not needed. That is for we are, you remember that we are going to make that x y and other thing, x y we are making. In that x
Yes,
y,
sir.
the source node and the destination node is not needed. It's not going to give any relevant to that. And label also we are removing, because why we are doing a label is important. It will be going to be work it in a why it is going to keep that up. So that after removing these three field, you are looking that you are having that this much columns will be there. There are totally 45 fields are there.
Yes, sir. 45, sir. 10 lakh something and comma 45 is there, sir.
Yeah, it is
The
there.
top.
45 is there. Now we are removing
Yes,
that
sir.
three things we removed.
Means three columns
Three
itself.
columns we removed.
Label.
Three columns we
Okay.
removed. We removed the three columns. Then we are looking that that is a info. We are looking that everything you want in a integer format, integer and float only it will be available. So that everything will be come in the integer and float only be coming it. Okay. Now what we are going to do means we are going to uh, take the important features only. We are going to take that. What is one by the important features means I told you earlier also, again I recollect you, there is one thing called correlation will be there. For example, there is one project we are doing that we are going to identify the one person age. There is columns are there is height, weight, is hair color and skin wrinkles, its walking speed, and is
Mm.
address, pin code, everything is there. And finally we are having one column like that is age group, is a class A. Class A means 60 to 70, and class B means 50 to 60, like that will be there. Okay. Now that hair color will be more correlated with the class, correct? No, age.
Yes, sir.
And height, weight will not that much correlate with the age.
Yes, sir.
Correct, no? So that the hair color will have the more importance, and the skin wrinkles will come more importance. Walking speed also little bit come into the importance, whereas height and weight will have the less importance. Like that, we are going to identify with the our target feature is a attack. With the attack, our in that example I told you, age is our thing. Here we are going to identify correlate with the we are going to correlate with the all the feature. We are finding the correlation with the all the feature with the correlate with the target feature. We are doing that. Based on that, it will give the important. This is the features. This is the importance values. It will come. We are getting the important values, so that we are
Okay,
getting
sir.
that the which are the positive values we are taking, that these features are not needed for us, negative values, so that we are removing that we are removing that above 0 only we are keeping, remove the other things, so that it will
Mm.
come that 0 to 28 features only we are taking it. 0 to 28 features we are taking it.
28 and 29 features. Okay, total. Okay.
Then it is on plot for that, which is the highest important. That L4 DST port is very important. It is very important. Next in TCP Win Max out is next important. Like that, it's having importance. We are showing that it is for the visualization purpose. Then the selected features only we are storing into one place called trained models. In that selected features that PKL we are storing. Why we are storing? For the future use we can able to do that. So that in this thing we are having one folder called models. In that model it will going to be stored that trained model. In this thing selected features.pkl. PKL is a pickle file. It is a encrypted file. We can't able to open and see the data. We are storing this feature details inside that. Okay. We are dumping into that. Then after that we are having that head. We are having that the head. All the 42 columns are there, but we don't want all the 42, so that we are making the only the selected features only we are keeping it, and plus we are adding the attack, so that selected features is a 29, and that 0 to 28 it will come 29, and you are adding that attack means it will come the totally 30 features it will come, so that the final our data set will be 30. That is a 5000 comma 5000 attack, each attack 1000 and 30 we are taking it. Then what we are going to,
Mm.
this is the final our data set. It is a pre-processed data set. Now we are going for x and y. For x, without that attack we are taking that it is an x. It is a directly also we can do. For learning purpose we are adding the attack and removing that, so that without that attack we are taking it an x, so that attack will not be there. Here we will get the attack will be there in this thing data set. Attack will be there. Now it is a x. That only that attack we call it as an y. Okay. Then we are going to make one thing called normalization. Normalization means these values are there, no, this data values we are converting into 0 to 1. We are converting that. For that we used one thing called the min max scalar. We are using that. For that min-max scalar, we are using a one object, scalar object we are creating, and we are giving that the x value only, no need of giving the y values, so that it will be convert all the values between 0 to 1, it will convert. You can see that now every values will be converted to 0 to 1, the x value. We are not
Mhm.
touching that the y, that is attack we are not touching. Only we are adding that the x value only we are doing that. This scalar value also we are storing in a scalar.pkl. It will be going to be stored in a trained model. It is called scalar.pkl. That is a normalized data we are storing it. That is also we are dumping it. Then we are going for the splitting purpose, we are coming to the picture. We are giving that the x and y we are giving it here, and we are telling that 20% will go for the test data, and the remaining 80% for the training purpose we are using that. So that what will happen, 80% data will go for the x train, will go 80%, 4000 record with the 29 features, it will go for a x train, and y test 1000 records with 29, and the remaining things are 4000, whether what type of attack it will be, one column only, 1000 records will be the y test, that thing it will become. We are storing all this thing in a train test data, x train, x test, y test, we are storing it here, the one folder we are having the train test data, in this we are storing it. We are open that the test x test data, it will have that all the normalized data, it will be there, 1000 records will be there. 1001 it will come,
Mhm.
because it is starting with the first header. And
Yes,
why
yes, yes, sir.
test is taking that, you will get that only that attack name only will be there, 1000 attack. It's answer,
The
that
zero one.
32 type question means it is the answer, it will come into the picture. Okay, this is the file pre-processing.
Mhm.
Over means, then we are going for the model training. The model training, we are reading the data from the test train data, what we divided x train, x test, y train, that we are taking it, and it is coming 4000 record for the training, 1000 record for the testing we are giving that, and we are printing that x train head, y train x, these are just for formality sake we are doing. Here only the main model, that artificial neural network, what I teach you the same thing, only data set will be we are changing, so that the two categorical I explain you, you remember that, I think, that six wise I told, Ram, Sita, Shiva, you remember that two categorical?
No, sir, I didn't say that.
Okay, what
Yeah.
meant by two categorical? No, actually, why why you will be having that one only be there? No, now we can able to go with an, it will be converted into five. Why we are converting into the five means, I'll give an example to you. It's a neural network. No, neural network, machine learning, it will give that whether you are giving that a question, it will directly tell the answer, but neural network will always give the probability. For example, name, it is a sex will be there. Now Ram will be there, Ram will be male, Sita will be female, and Shiva will be male, and on X will be transgender, like that will be there. Now for male we are keeping 0, female will be 1, male is again 0, transgender we can keep it 2. Now I am giving the name, our model has to identify whether it's a male or female. One example I am telling that, like that we are going to identify. Okay, in a machine learning model we train this model means, I am giving that RAM means, it will directly give 0, 1 or 2, anyone it will give directly. Whereas in a deep learning, how it will be work means, male, female, and transgender, it is called one hot encoding. The concept is called one hot encoding. Here Ram is male, no, so that 1 will become, remaining thing
One.
will be 0, 0 it will come. So for Sita it will come, 1 will become here, remaining thing will be
Zero
0,
zero.
0 it will come. For Shiva it will be 1, 0, 0. Can you tell me the transgender, what it will come for X?
It will be two, sir.
0,
200.
0, 0, 1. It's come like that.
Oh,
Now
sorry,
here
it is there. T is the
0,
last
0, 1.
column. Okay.
Now This is a zeroth index, it is the first index, it is a second index, correct? No, that is the index.
Okay, sir.
Now
Got it.
you are giving a after train the model, it is our, this is a our y data, but we have to convert into three columns. Why three columns? In our thing, three classes are there. In your project, five classes, it will be converted in five columns. It is called one not encoding. One will be there in a one place only, remaining thing zero will be there. Okay. Now why we are doing like that means, in the machine learning, it will give directly output. Of deep learning, you are giving gram, it will give the three probability value, it will give three probability value will be, ram will be male will be 0.89%, ram will be male, and 0.23% he may be female, 0.11% ram may be transgender, like that will come. Now these are the three output it will come. Now what we have to do means, it is our X test data. It is our X test original. It is our prediction. It is our prediction. We are giving that our prediction. It is coming. This is the original data. Here argmax we are giving that which argument is max, a zeroth argument. It will come, zero will come. In our original thing also, it is our prediction. Here argmax means it also zero. So that what will happen? It will become correct. Now I am giving
Okay, sir. Got it.
Sita. I'm giving Sita, it will give like this. Maybe it will be 12% chance will be male, 0.92%, 93% is a female, and 0.33% transgender, like that will come. Now Sita will be, the arguments will be 1, it will come. It is a,
One. Yes,
also
sir.
it will come that, it is also come 1, it is coming correct, correct. We will see that
Okay. Yeah.
fault case. Now Siva, I'm giving that model little bit confused. For example, it is giving
Point
that
ninety three percent.
0.93.
Point
It
nine
is
three.
giving on a assumption only. These values are, I am only giving that.
Yes, sir.
0.57 it is coming. 0.34 it is coming. Now what will happen? Siva, the argmax will give that 1, it will come. But original Siva, it will have argmax will be 0. This is become wrong. Correct, no?
Okay.
So that it will have confused. You are a human. I will show one photo. I'll ask you whether the person in this photo is a male or female. You can see that a female is wearing a sari, means you will straight away will say that 100% is a female, you will tell. Correct, no? Suppose a
Yes, sir.
female is wearing a t-shirt and jeans and a crop cut, look like a man, you will tell, sir, I am doubting she is a female. But I am asking that what is the percentage, your percentage will be, confidence will be reduced now. You will tell 60% I
Yes, sir.
think she is a female. Correct, no?
Yes, sir.
Sometime one male will be look like a female only, dressed saree, everything. You will be calculate wrongly also. Correct, no? Little bit calculation here. You can see no 1% only be difference. So that will be wrong.
Okay. Yes, sir. Yes, sir.
Like that will come. So that converting the single thing into the multiple column, single column to the multiple column, it is called two categorial. The two categorial will be achieved through this function. So that y train also we have to do, y test also we have to do. You are seeing that no, it will be converted into five things, it will become into the things.
Means automatically it converted to 5, or we are giving this 5
Two categorical
value.
function. Why it is a 5, it is coming, your class labels are 5, correct, no? In your
What is class level,
pre-processing,
sir?
in your pre-processing we are having a 5 categories only now.
Where 5 category? Means categories means layer,
Column
column
names
names,
and
sir. Okay,
rows
the
and everything,
attacks.
correct,
Okay.
no?
Okay, sir. Okay, sir. Got it.
So that you want your we can able to open your y test.
It's first, sir. First one.
See how it will be converted. No, it will become a 0, 1,
I got understood, sir. What you said. 0, 1, 0.
3, 4.
Like
It
that.
will come means, it is a 1 means it will come here only 1. Remaining thing it will come 0, 0. It will come.
0, 0, 0. Okay, understood, sir.
That is only it will come. Like this it will become 3 means it will come here only 3. Remaining thing 0, 0 will come. That is a converting
Yes, sir.
like this to this category. It is called the one not encoding.
Okay, sir. Means we have 5 categories. That's the reason it's converted. The value is 5. Okay.
Now, now I told you already the neural network will have the three layers: input layer, hidden layer, and output layer. Here our input will be, we are going to give the this 22, 27 speeches we are going to give, and it has to going to identify among these 5 attacks which is the, among these 5 which one it has to tell. It is going to give the 5 probabilities. Like Ram Sita, how we are doing that, no, 5 probabilities going to give. that is only it will be 5. That is called the, it is a output layer. This is a input layer. You got it, no?
Yes, sir.
So that remaining things are, these are hidden layers. Each hidden layer is a, it is a multi-layered, it is a multi-layer perceptron also you can call it, or it is called the deep neural network also you can call it. More than, some people will do only with one layer also they will try to do, but in your project to get the more accuracy we are using 5 hidden layers we are using. It is a one hidden layer, it is one hidden layer, it is having a 64 neurons, it is having 128 neurons, 128, 128, 256, like that we are doing that. RELU means RELU, it is an activation function. What it will do means it will convert the negative values into the 0, that is a RELU, it will do that. So that it will, in
Sir,
this
what?
case,
No, yes, sir. Continue, sir.
yeah, it is converting the negative values into 0. So that this
Zero.
27 features will be go on to connect with the 64. It will do some small calculation. It will be transferred to the 128, next 128, like that will become. You can able to see
Sir,
that.
what is the 64 and 128, sir? We are giving or automatically it will take, sir?
Okay, I'll show you. This is a single layer perceptron. You can see that now input,
Okay.
output, only one hidden
Output.
layer is there.
Okay,
You
sir.
see that now? One layer. You can
Yes, sir.
see this thing here, they are having a 3 hidden layers are there. You are having the 3 hidden layers. In the first hidden layer, we are having a 64 neuron. The circles are there, no? It will have the 64
Yes, sir.
neurons are there. Second hidden layer, 128 it will become.
Okay, sir.
That is the concept we are doing that here. And why we are
It will
giving
take
this?
internally or we need to define the
Yes,
value, sir? 120,
it is
64.
a permutation combination only. It is there is no fixed rule for this.
No, we are going, is a user defined or automatically it will convert, sir? 60, it will take
The
by.
program will convert, but whether it is a 64 or 128, it will be our hands on. This green colors we have to give. I tried to fix this model. We tried this training more than 10 times. We did it more than 10 times. I trained. I can see that.
Like for first, how much you gave, sir? Like just for the knowledge purpose, I'm asking, sir. How much you gave? Then what was the output? Just want to understand that how.
Prathan, I made it. I tried with 32, 64, 128, 256 like that. It's a
Okay,
50
sir. What was the change we got output?
it is getting only the 70% only accuracy it got it.
Okay. Got it, sir. Okay.
Then again
How many years?
I tried with some other permutation combination. Now we are
Okay, sir.
trying
Okay.
the model, we get a 90% accuracy.
90%. Okay. Again, we can tune it, sir, by changing the values.
I tried nearly on 10 20 times we tried more than this you try above
Okay, sir.
90% you are giving is it is a good thing. Above 85% only they'll accept that is a good program.
Okay, sir.
So that we made this thing. And here the Adam is a optimizer means is you are writing an exam in your college, your 10 revisions you are doing means your teacher will be keep on telling you are doing good in this exam, you are weak in algebra, you are strong in calculus, like that they'll the correction maker is the optimizer. That maybe cricket team coach is optimizer, each time they will give the things. Okay, this is the input layer and output layer, and optimize we are setting that, and we are measuring your thing with the metrics we are doing that, accuracy metrics we are doing that, and the last categorization will be by the categorical cross entropy. What is by the categorical cross entropy means I told this is a 53% it is telling that the Siva, 54% it is selling that the Siva is a female and male.
Female.
No,
Female.
this will be the how much loss it is having the thing here. The confident level will be 11% loss, correct? No, here it will have the
Yes, sir. Yes, sir.
54% loss, here 53%. That calculation it will be understand why it is having this much confusion. It will check that why this answer become wrong, like that it will be to look, so that
Mm-hmm.
we are little minute only, we will correct that. It will be come like this means it is a very wrong. 11 it is coming, here it is coming that 90 it is a blunder mistake, correct? No,
Yes, sir.
this is a very blunder mistake. Whereas 53 54 means a little bit only we correct means okay. Here major correction we need in our model. That understanding will be
Yes, sir.
automatically taken by this categorical cross entropy method. It will be calculated that. Okay. So that whenever we are giving the fit, we are giving that X train, Y train, we are giving that, and validation, it is for the student training purpose, we are giving that. We are conducting the 50 exams, internal exams we are conducting. This accuracy is students are writing the exam in their home, and once they are coming to the college or school, we are conducting the test with the X test, Y test. This is the unknown to the model. These are known to the model. X train, Y trains are known thing to the model. This X test, Y test are unknown to the model. So that you can see that the year first they are getting that the in the home exam they got 90% for 90.72. In the college exam they got 0.90.50. They are getting the accuracy like that. In the beginning you can see that now, like that it will be there. Accuracy, it is a training accuracy, this is a validation accuracy, they will tell. So that for that we are plotting the graph. In the beginning that is a validation accuracy. Validation accuracy will be starting with an 82. Training accuracy will be start from the 62. Then gradually it is improving. Maybe around the 20th epo it will achieve that the good result, around 90%. We trained up to 50 times also, that model will be not increasing more than 90%. So that we finalize that with the 50 things. Okay. This is a loss function. Loss
Okay.
function means it is like that. For example, 90 is the accuracy, means loss will be 10 only. But why it is coming at 21, it is coming means you are writing on objective type question, you got a 90% mark. That means you will not 100% strong on the 90%. Only 80 question only you know the answers clearly. Another 20 question you put guessing. In that guessing you got 10 mark plus. So that your loss is 21. For 21 questions you are not very strong. You are strong only for 79 questions only. That is a loss. You got it, no? The
Yes, sir.
loss will
Understood.
keep reducing. So that the loss functions also, in the beginning it will be a little bit high, and it is reducing, it is coming to the around 20% loss, we are getting it loss. And then predict, I told you know that whenever we are giving the Y test it will give the 5 values. How we are giving Siva, it will give the Ram, Siva, three thing. In your thing 4
Okay.
classes are there, no, it will give that the 5 probabilities it will give. Using the argmax we have to find the thing. You can see that the argmax function for the first thing, which argument is max, means a 0 1. This first argument is a maximum, correct? Now it's so that it will coming 1. In a second thing you can able to look the things, which argument is will be the maximum, means maybe this is a maximum, so that it is coming
Yes, sir.
2. 2 it is coming like that will become. So that argmax will take that, and it is a original answer. This Y test is a original answer. This is the original answer. This is our answer, predicted answer. From the original answer also we are taking the values. Then after that result analysis, we are giving that the result analysis, both the original answer and the predicted label, we are giving that it is giving 90.50%, it is giving a correct answer. So that out of 1000 records we are given for testing, here 200 for the benign, 200 for DOS, 200 for the injection, 200 for password, 200 for scanning we given. And in that 200 it predicted benign 194 correctly. 4 is telling that DOS, 1 it is telling that injection, 1 it is telling the scanning, like that. So that it is giving the almost done only. But for passport attack it will not doing that much good. It is giving that 73% only, it is giving that accuracy. This is a passport attack 118, this model. So that we are saving this
Sir,
artificial intelligence.
one second, sir. Here, go to the diagram, sir. In the beginning, B9, just go to the that graph, sir. That come down. Yeah, this one. 194,4,101. What actually it is? Means like
Actually,
194 is
this
correct,
we
huh?
are giving that the benign normal 200 sample record we are given as a benign. Our model detected 199 correctly as a benign only. 194.
Okay, that's correct.
Correctly. There is 6 is pending. It do the mistake, 6 things it do
Okay, these
mistake.
are five column. This five different attacks, right? One first column, second column, third column,
No,
fourth column,
first
fifth
first one
column.
is a benign, is a
Okay,
normal. Normal.
okay, okay. I didn't saw that. Okay, sir. Understood. Got it. Yeah.
That is a normal. So that it is telling that it is a normal only, but it is telling 4 as a attack, and 1 4 as a DOS attack, 1 as a injection attack,
Injection,
1 as
password, and
a
scanning.
scanning attack. I
Okay,
that
sir. Understood.
DOS
Okay.
thing, it will predicted all the 200 correctly. Okay.
Okay. Mhm.
And we are saving this model as an artificial neural network model. We are storing the trained model. We are storing that in this thing called the trained model. It will be, we are storing that the model. Sorry, it is X Prathan. See your previous thing. Trained model. It will be stored. Artificial neural network will be stored here. Okay. Then after that, we are going with the convolutional long short-term memory. It is a CNN plus convolutional neural. That is CNN is called convolution neural network. Long short-term memory is a RNN. In a neural network, there are three things are there. ANN, artificial neural network. CNN, convolution neural network. RNN, recurrent neural network. Further, this RNN, they divided into, they improved this thing to LSTM and GRU. It is improved version of RNN, that is called long short-term memory. RNN will have some issues. That issues will be overcome with the LSTM. That RNN will have one problem is gradient diminishing problem. It is having RNN. What is with the gradient diminishing problem means? For example, I am asking you where you had the breakfast today morning. You can tell. Yesterday, little bit difficult, you can tell. 1 week before, very difficult, but you recollect and tell. But 1 year before, definitely you can't able to tell where you had your breakfast on the same day. That is a gradient diminishing problem with the RNN. But 1 year, it is not necessary you have to remember that all the things in your brain. But 1 year before, you had a breakfast with some celebrity like Virat Kohli or some Amitabh Bachchan like that. You should remember that, no. That is also this RNN will forgot. So that only they come up with an LSTM, that is called long short-term memory. It remember the important long memories and also to remember the short-term memories. Now we are doing the hybrid network. In this hybrid network, what we are doing is we are doing with an CNN, convolution neural network, plus LSTM we are using that. It is a hybrid neural network to check that whether it is performing better than ANN. Like that we are looking that. And it will give the good result. We are getting that the accuracy better than ANN. It is your data set is a little bit challenging data set. It is giving that the almost 3% increased, 92.9, that is a 3%. It will give the increase.
Okay, that is AN. This is the conventional. This is LSTM. Okay.
Plus thing, it is giving 93% accuracy. It is giving, that is a 90%. 3% we increased. Here the convolution neural network, usually they will use it for the ANN. Generic thing is a ANN for the numeric data.
Okay, sir.
CNN for the image, and RNN for the text, like that. It is a general concept, text data. But
Okay.
internally all are numeric only. We can use ANN also for image classification, CNN also numeric thing. But only thing little bit we have to change. In computer thing, image is not 2-dimensional. It is a 3-dimensional. You understand, no? Image is a, for example, you are going here. This is a one image. Image is a
Yes.
2-dimensional. Rows and column will be there. But internally,
Yes,
the
sir.
image you are taking any one pixel you are taking, it will have the red channel, green channel, blue channel will come. Correct, no?
Okay, sir.
So that the image in computer, we are calling it as an, for example, I'm telling that one image is a 200 by 200 means 200 comma 200 comma we have to give 3. That 3 represent the red, green, blue channel.
Okay.
Actually your data will be how your data will be there. For example, we are having training data 4000 comma 29 features will be there. Correct, no? 4000 comma 29
Yes, sir.
features are there. Here now we have to add that just one, that is no different, no. It is a 4000 comma 29 also same comma 1 also same. Correct, no? Actually what is meant by
Why are you
CNN?
showing me this difference, sir?
Yeah, actually for CNN we have to give the 3-dimensional data as a input.
Okay, three dimensional. Okay.
For
We are using
example,
LSTM. That's it.
yeah. For example, you are having a one In that one page you have to identify one word, means you have to tell the row and column, you have to tell, correct? No, row and column. In a book means you have to tell that the which page number, which row, which column you have to tell, correct? No,
Yes, sir.
you want to convert it. Now in I want to convert this one page only, I want to convert into the three dimension, means just I will add one, that's all. Always going to be one page only there, correct? No, it is a just for converting the two dimensions to one dimension, just we will add one. Don't think much. That's all. Here we are doing that. That only we are giving that the X train, Y train. We are adding just one. We will add it for the training also. For testing also we have to add one. Usually it is a two dimensional. We are adding that 4000 comma 27 comma 1. Why we are doing like that? Because for convolution neural network we have to give that the two three dimensional data, it will need that, so that we have to give that like that. It is a it become that 0, this 1000 become 0, 27 become 1, this will become 2. Okay, that is a 4000 become 0 1 2. We are seeing that the X train phase 1 means 27 features we are giving, comma phase shape 2 means 1. We are giving 27 features only, but we are adding that 1, that's all.
Okay, sir. Okay. It's a three-dimensional. That's the reason. Okay.
Input. Then we
You
are
have to
getting
give
that
three inputs
output.
also.
Output also same thing. We are getting the output 5 unit. We are getting a output is a 5 unit. We are getting it. Okay. In a convolutional neural network, there are it is not like a ANN. There are some little bit layers are there. What are the layers are there? Means convolutional layer is there. Here the one thing called the convolution layer will be there. We are using that convolution layer, and we are converting that. Okay, converting the data. It is a little bit professional thing for image processing. No, it will come the convolution layer. We are adding it convolutional 1D layer. We are adding it. Okay, convolution 1D layer. One second, you can assign the work to the 5 minutes ago. Okay, then up to this, it is a hidden layer. It is a input layer, and it is a one hidden layer. It is a second hidden layer, third hidden layer, and the fourth hidden layer will be there, fifth hidden layer. Then after the 5 hidden layers of the convolution neural network, we are adding the LSTM. The LSTM layer, we are adding the 2 LSTM layer we are adding with your project. That is also bi-directional we are adding. What is bi-directional? Means it is more professional. It will check in the both the side. Left to right, right to left, it will check that. That's all.
Okay.
Then after that, we are getting the output. Again, we are also having that the Adam classifier will be there, and the categorical cross entropy will be there. We are doing the same thing what we are doing that.
Accuracy. Okay, same thing. What we did here.
I will send you one video for the CNN. You watch that video, you will get an idea. You have any doubt also, it will clarify you. This is the structure of this model. Now we are giving that the fit command. We are giving that the X train, Y train here. Similarly, we are going to check with an X test, Y test. We are giving that, and it is giving that the 50 epoch. We are doing it here also. It is also doing that same thing. It is a training accuracy, it is a validation accuracy, and gradually training accuracy will be increasing. It will come to 93%. It will come the training accuracy,
Yeah.
validation accuracy we are getting 92%. For that we are doing that the graphs also we did it, so that after the 120th epoch only, maybe in the 15th epoch only, it will become straight. And here also we are getting that the epoch. Similarly, that predict model we are doing that, argmax we are doing that, we are getting that the result is a 92.9%. We are getting almost, it will be little bit good. You can see that, no, everything it will giving a good. It is a very deep
Mhm.
work we are giving. We are saving this model convolution short term memory we are saving. Yeah.
Mhm.
I'll
Okay,
start
sir.
preparing your report. The result analysis and the model thing is pending. We will complete maximum 1 or 2 days. We'll complete your report and I'll give to you.
Okay, sir. And
Until the last day, we'll support you. Don't worry. Until the
sir, like one thing I didn't get you was about like initially you'll give me like I have to demo I have to demo this I have to exit this project and I have to show them, right, like how to start from the beginning, like here.
whether your college is asking a demonstration, project demonstration.
Like we have a Viva. I don't know whether I think we need to execute the project
Not
and
a problem. What you have to do now, you go to the, you will deploy it in your system. Okay. Now
okay,
go here and make one copy. Always make one copy. Make a copy.
okay,
Don't touch it further. Make one copy in a file. There is a one make one copy will be there. Now you go to kernel, restart and clear output. You can make it.
okay. But for few things
Output
like
is
it will
output is
be
gone. This is your coding. Then I will
okay,
what you have to do means you have to keep the cell here, shift enter, or you can press this run button is there no? Run but shift enter
okay.
or run button. You can run that.
At the last line, you one by one, you have to execute, huh?
You have to do.
Yes, sir.
Otherwise you can have the kernel restart run all means you can it will run all the thing, it will come quickly. You see that now restart
Okay.
run all means it will run everything quickly, it will run it. But
Like
you can see that it will be executing everything.
sir, one thing like while demoing, if they ask me to give a run this project and show the output means like one like unit by unit we have to section by section we have to execute or like once as you said na like run all
That is your
using that
guide is
option.
having a patience. You can show one by one cell, it will be good. But some guides will not having that much patience because he is having more students are there. Then they will not ask you. Just they will see your Jupyter notebook. They will go. Most of the time from your college they will not run all the things. Maybe very few guides only ask them to run and show the demo.
So can I run it earlier itself and keep it ready and
Yeah,
just show the
you
output?
try. Always you should be better. You have to run it and keep with you.
Okay, sir.
Okay. Once we deploy the
And
code in your system, you run it and practice it. You should be always ready for that.
okay, sir. Okay.
Hmm? So that I will ask your. I will ask him to deploy the code in your system. You can able to
Okay,
start
sir.
practicing this thing. Any questions are there? Just to take one photo and send me in WhatsApp. You ask your question. I will clarify you. Okay.
Okay, sir. And
Okay.
sir, one more thing, sir. Last out. Just open that document, sir. ANN, CNN, and LSTM. You show me you gave me the difference, right? Not this one. In the paint. Yeah, yeah, yeah. Sir, why like we are showing like comparing two reports, right? One is by implementing using ANN and using LSTM. That is CNN with LSTM. We are making a hybrid model and we are getting more accuracy compared to ANN, right?
Yes. Yes.
So what is the difference in that, sir? Yeah, accuracy means in terms of what? Like, what is the difference? Why we choose this LSTM, CNN with LSTM,
Yeah. Actually,
not only LSTM.
there are two types of things are there. For example, you are having a one exam will be there. Okay. For that exam, you are selecting on 5 questions and you are thinking that this is going to become like the randomly you are picking. That is not, that is assumption. Correct, no? But you are having tomorrow an exam. You are making one like the dip and selecting some algorithm means that is assumptions. Correct, no? That is not correct
Okay.
method. But you
Yes,
have
sir.
to do the one 5 years question paper you are selecting, and from that you are recognizing the pattern, everything you are calculating. This will be best means that is a intelligent guess. There is a difference between guessing and intelligent guess. Correct, no?
Yes, sir.
So that we in the literature review we will make like that, we will look that sometime the hybrid neural network is giving good performance than the neural network, like that we'll put the research gap.
Okay.
You have to tell that I tried with the ANN, it is not achieving good accuracy for this data set, it is giving not good, it is giving good accuracy. I tried with an hybrid neural network, thought of it will give more accuracy than the ANN. Yes, I got it. That is your gap analysis you are doing it. Already petrol car is there, diesel car is there, and the electric car is there. Then they thought of one idea, no, hybrid car with the electric thing to start the
Petrol and
then
electric.
petrol it will go like that, it will give good mileage. It is happening, no? That is called intelligent guess, and you proved that it is working good also.
Okay. No, technically speaking, like see, like why we I use CNN with LSTM.
That is hybrid model means we have to go with an always any project you are doing, ANN will come. Generally, we are telling that anything we are doing that the final thing will come with a dense net. It will come even in this also. You see that now final output will give to the dense. Dense is a ANN. So that remaining two network is the only CNN and RN only. We have to take from this only anyone. Correct now?
Okay.
So that among these things we can able to take, we can go with an CNN with RNN means CNN LSTM is there, CNN GRU is there. You tell I did with the first try because of time constraint. I did with the one try only. It is coming good. I keep quiet. That's all.
Means CNN with LSTM I tried in due to short time like.
More accuracy, I am okay with that. My research, maybe
Okay.
further research we can do with an CNN with the GRU or some other thing we can do that. Yeah.
Okay, sir. Okay. Just we have to define that. So okay. Okay. Okay.
Yeah,
Like
yeah.
this.
Maybe
Okay.
you have to look
Understood.
out in the literature gap. It will come.
Okay, sir. Okay, sir. I'll go through that. Sir, let me know when I can make a payment, sir. How much
As soon as possible. Okay, you make it remaining
like
payment.
how much, sir?
Today I already.
10,000 I have paid.
Pardon?
So 10,000 I have paid remaining.
Remaining, I think.
Uh,
How much is there? Your thing.
30,000 you told me, sir. Proposal is different. Like I already paid for that
Yeah.
5,000.
Then it is coming to you 30,000. Remaining 20,000 you make the payment. Yeah. Okay.
Okay, sir. I'll make it today. Yeah, okay, sir.
Okay.
Yeah. Thank you, sir. Okay. Thank you very much.